Hello everyone, I hope you guys are doing good and staying safe. Welcome to SimpliCode's YouTube channel, and in today's session, we'll be discussing various types of linked lists. Now, linked lists are amongst the simplest and most common data structures used, and they are conceptually very simple, and it will provide a foundational knowledge before you move ahead to other data structures. Now, in a previous tutorial, we have discussed what is linked list and how they are implemented. So if you haven't checked that out, make sure you check that out. We will leave the link in the description below. And in today's session, we'll be understanding the various types of linked list and how to implement them in Visual Code. So without any further ado, let's get started with today's topic. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the latest tech content. And hit that bell icon to never miss an update from us. So before we move ahead and discuss the various types of linked lists, let us have a quick introduction to what is linked list again. Now, a linked list is a dynamic data structure used to store a collection of elements. Now, unlike arrays, where elements are stored in continuous memory locations, linked lists allow for efficient insertion and deletion of elements at any position within the list. So you can consider a linked list is like a train where each bogie is connected with links. Now, a linked list consists of a series of nodes where each node contains two fields, a data field to store the element, and a pointer field to link the next node to the next node in the element. So the first node in the element is called the head node, and the last node is called the tail node. So if you look at the example here, we have a start, which is a head pointer, which is holding a value 100, where the start pointer holds the address of the first node of the list. Now we have four different nodes, and each have different elements like 10, 20, 30, 40, and the first node is storing the element 10, which is having an address of 100, and it is pointing to the next node, which is storing the address of the next node, which is 200, and so on, and until the final one where the next field of the last node is null. Now, let us discuss the types of linked lists. Now, linked lists are divided into different types based on their properties and functionalities, as each type has its own advantages and limitations. Understanding the different types of linked lists help developer choose the appropriate type for a specific application or problem. Now, some reasons why linked lists are divided into different types are: first one is efficiency. Now, different types of linked lists have different time complexities for various operations like insertion, deletion, and traversal. Therefore, selecting the appropriate types of linked list based on the efficiency requirements of the application can significantly impact its performance. Next, we have data organization. Depending on the data organization requirements, let's say a specific type of linked list may be suitable, but another will not. For example, if the application requires a sorted list, a sorted linked list may be more efficient than a singly linked list. Next, we have functionality. Now, different types of linked list offer unique functionalities that may be beneficial in certain case scenarios. For instance, a circular linked list, which is one of the type of linked list, can be used to implement round robin, scheduled in operating systems. Next, we have memory management. Now, the type of linked list used can affect the memory usage of the application as well. For example, if the applications require, two-way the bidirectional traversal, then a doubly linked list may be useful, but it would consume more memory than a single list. So based on all these factors, we have three different types of linked list, which is singly linked list, we have doubly linked list, and finally circular linked list. So let us discuss each of them in detail now. So firstly, what is a singly linked list? Now, a singly linked list is a linear data structure used to store a collection of elements such as, let's say, integers or any objects. Now, it is called singly because each element in the list contains a reference or a link to the next element in the list, but not to the previous one. So this is basically unidirectional, and it is the basic of all the linked list. That is why we are calling it as a singly linked list. So in a singly linked list, each element is called a node, and it basically again consists of two parts: the data that it contains and the reference to the next node in the list. So the first node in the list is called the head, and the last node is called the tail. So to create a singly linked list, first we have to create a node. Now each node will have two data members, an integer value and a reference to the next node in the list. So you can see in this diagram here, we have the next pointing to the next node. So this class will have two data members, a head node. So you have the head node and a tail node at the end. So the head node will store the first element in the list, and the tail node will store the last element in the list. So this is this one, which is having the address 4. Now to add an element to the list, we need to create a new node every time and set the next reference to the previous tail node to point to the new node. Then we can set the new node as the new tail of the list. So I hope you understood what is a singly linked list. If you want to know more about it, make sure you check out the linked list tutorial where we have discussed about them in detail and executed various problems also, so that you'll have a clear-cut idea. Now, let us now move ahead and understand what is a doubly linked list. Now, a doubly linked list is a complex linked list when compared to the singly linked list. So, it is a type of linked list where each node in the list contains a pointer to both the previous and next nodes in the list. So, this allows for efficient traversal of the list in both forward and backward direction. So if you look at the example here, let us now understand how a doubly linked list works. So if you look at the node here, a doubly linked list contains a series of nodes where each node contains two pointers, one to the previous node in the list and one to the next node in the list. So you can see this here, it is pointing to this and back to this. So additionally, each node also contains some data that is stored in the node, and we have the address of that node as 2000. Now we have the head and tail pointers again, which is the doubly linked list has also two pointers that point to the first and last node in the list. These typically are called head and tail pointers. So if we talk about the insertion process, now in order to insert a new node into a doubly linked list, you first create a new node and set its data value. Then you update the pointer of the neighboring node so that the new node is correctly inserted into the first node. So if you look at the example here, we have if you want to insert a new node between nodes, that is the first three nodes that you have taken, you first update the next pointer of the node, which is this first one, and then you have to point to the new node and then update the previous pointer of the node B to point to the new node. So in this example, if you consider three elements as in the three nodes to insert into that list, each node consists of the data and the addresses parts of the previous as well as the next node, that is stored at a random addresses like 200, 201 and 202. Now the address of the first node is stored in the special node called the head node. So the first node's previous pointer is pointing towards the null value here, alright, indicating no nodes before it. And the last node of the next pointer is pointing to the null, which shows no nodes after it again. So every node in a linked list connects in a two-way here in doubly linked list, that is forward and backward direction with the others through the pointer called previous and the next, that points to the address of its previous and next node. So in this way, every node links with each other and arrows in the diagram which is being represented here. So let us now understand this is an example here. So let our elements to be inserted are 10, 20, 30. The first node next pointer holds the next node's address, that is the address 1, which is 200, and its previous pointer points to the null. Similarly, the second node, which is this, holds the address of the third node, which is 201, alright, and address 3, and it previously holds the address of the first node as well, which is the address 1, which is 200. So whereas the third node previous pointer is holding the address of its previous node, that is this one, which is storing the address of 201, and the next is pointing to the null. In this way, they link together in order to form a doubly linked list. So let us now understand the syntax of doubly linked list. The syntax is followed as we are using a structure here. So basically, we are giving a structure node and we are giving a data type in data, and we are initiating two structures, which is a previous and the next node. So let us now move ahead and understand what is a circular linked list. So when we talk about a circular linked list is a collection of data called nodes where the last node is linked to the first node. So the traversal, that is the search operation on each of the node of a circular linked list, is done until we reach the same node which we started in a list. Okay. So let us now understand how a circular linked list is represented. Now, in order to implement the circular linked list, we maintain an external pointer called last. Okay, that points to the last node in the circular linked list. Hence, last points to the next will point to the first node in the linked list. So by doing this, we ensure that when we insert a new node at the beginning or at the end, we need to traverse the entire list. This is because the last points to the last node while the last pointing to the next points to the first node. Now I hope this is a bit confusing, so let's just clearly understand how the understand the memory representation and how it works. So first, let's consider 4 elements to insert into a list. For this, we create 4 nodes here, which as you can see, we have where each node consists of data and address parts stored at some random addresses. Now the last node's next pointer points to the null in the singly linked list. But when we compare a circular single list with a singly linked list, we don't find a null value here. This means in a circularly linked list, the last node's next pointer, that is, this is the last node next pointer holds the address of the first node. Alright, in other words, we can say that the tail node address, which is we have this one, tail node's address is pointing towards the head node of the linked list. So every node in a linked list is connected with the other through a pointer that points to the address of the next node. So let us understand this with an example here. So let our elements to be inserted are 10, 20, 30 and 40. So as you can see from the above diagram, the last node's next pointer, alright, the next pointer is pointing to the address of the first node, which is address 1. So the next part of the first node holds the address of the next node, which is address 2. Similarly, the second node is holding the address of the third node, address 3, and the third node is holding the address of its next node. And the last node basically holds the address of the first node. In this way, they have been linked together. So in a circular linked list, a reverse traversal is possible with less memory usage than in a doubly linked list. So I hope you understood this. So let us now jump into Visual Code and try to perform some operations like insertion, deletion on doubly linked list and circular linked list and see how they work. So as you can see, Visual Studio Code has started. Now I'll not be discussing the singly linked list example. We have already discussed in our previous tutorial, in our linked list tutorial. So make sure you check that out. So we will just directly jump into the doubly linked list program where we'll try to implement using some operations like insertion, deletion and see how it works. So let's just get started. So the first program will be implementing a program using doubly linked list. Alright, so mention the header files hash include iostream using namespace std. So firstly we have to define the node structure, right? So I'm using a struct keyword and I'm specifying a node here. Open the brackets and inside that we will initiate the data element. So I'm taking int data type. Now next we have 2 pointers that points to the previous node and the next node, which is basically the thing of a doubly linked list. So I'm just creating a node, a pointer which points to the previous one, as well as a node which points to the next node as well. Alright. Now once you've done this, we have to basically define the linked list data structure. Now we know that doubly linked list has a head and a tail. So for that we are trying to initialize them by defining the node of the head and the tail. So struct. So let us take a function here which is let's take doubly linked list, which we will basically call at the end. So here we are basically defining a node which is head, and similarly we have another one which is pointing to the tail. Alright, and with this, now next we have to check if the list is empty, otherwise the operations will not be performed. So for that I am taking a function here. Let's take so now since we are checking if the list is empty or not, which is basically a true or false statement, so I'm just taking a function, boolean function, and I'm mentioning this as is empty. So basically we are checking it on the doubly linked list, right? So we are calling that function here, which is doubly linked list, that we have already created in our previous thing. So let's just, inside we have called return. We are basically returning the condition. Oh, sorry, we have to take another parameter which is and list. So basically we are trying to understand if this list is empty or not. So for that I'm taking and list. So inside this we are saying list dot head. So if the first element in the head node is equals to null, then we will not return anything. All right. Now let's try to perform some operations on this doubly linked list. So firstly we will add a node to the, let's say, beginning of the list. So I'm taking a void function here and I'm taking a function name, let's say insert begin. Okay, we are doing that on the doubly linked list. So I am passing the parameters inside this and list, also the data, int data. Open the flower brackets, and now we have to mention the syntax for the insertion. Now the first node points to the new node, right? So node, I'm taking a new node, stores the address in the new node itself. So next, the working of the doubly linked list which we have discussed is, now the new node points to the data, so it stores the data for that. So the new node, whenever you point this new node to the data, it will store this data. Now next, since it's a doubly linked list, we have to mention the previous and the next node in order to store the address of the previous as well as the next node. So when the new node points to the previous node, it will be null. All right, and this new node, when points to the next node, will become the head, that is list dot head. That is the first element. So next we have to mention the condition also. If the list dot head is not equals to null, list dot head is not equals to null, that means basically we are creating a new node. So list dot head points to the previous node and it will save into the new node. So I hope you understood the logic here. Or else one second guys. Or else, now if the list points to the tail, we are again assigning it to the new node. List dot tail is equals to new node. Right. So we are done with the first operation, which is inserting at the beginning of the doubly linked list. So let us now try to add a node to the end of the linked list. Now almost the syntax remains same, just some of the iterations that has to be performed here. So let's just take another function. It's of void, and let's take the function as insert end, and then we are calling the linked list that we have taken, which is doubly linked list. Make sure the word is correct, otherwise it will throw an error. And list and int data are the two parameters that we are passing into this function. Now mention the algorithm that we have to perform on the doubly linked list, which is again node. If I take the new node, it will store the address, the data of the first node, that is the new node. Next, the new node points to the data and stores the data itself. All right. Now next, the new node points to the previous, which will basically store the data of the tail address. So for that, new node points to previous node and stores the address of the tail node. All right. And similarly, the new node, when points to the next node, will become null. which is basically the definition of the doubly linked list here, guys. Again, we have to mention the condition. So if list dot tail is not equals to null, then we have to point this tail to the next node, and it will save the value of the new node here again. And next, again the else statement, we have to give if list dot head is equals to the new node. All right, and let us now. All right, so we have also inserted an element at the end of the list. Now you can similarly perform any operations like deleting a node from the beginning of the list, or at the particular specific node also. So it is obviously of your choice. So I am not just printing all of them. So let us now try to print all the contents that we have taken here. So I am calling another function here, which is void. Let's take print list. So mention the arguments. We are passing the arguments, which is the doubly linked list we have taken. Doubly linked list and list cover int data. Oh, sorry, we don't need to pass this here, guys. Now we have to first check again the list is empty or not. Since we have already created another function for that, let's just call it right over here. So the function that we have taken here is is empty. So I'm just calling that over here is empty. That is, the list that we have created is empty. Then I will return cout. The list is empty. All right, list is empty. And I'll return the value again here. Return 0. Now, in order to print the contents, we have to write the code as node. So current is the node that we are trying to add value to our list. So list.head is the first value which will add the value to it. While, so we are performing an iteration here, while the current is not equals to null. So the first node that we are trying to insert is not equals to null. We are printing it out current data. Okay, current, and we are pointing it to the data that we have created. And current will point to the next again. So current equals to current pointing to the next. Close the brackets and cout end line. That's it. So let us now create a main function here to insert the values into our linked list by calling all the functions till now we have created here. So I am creating a main function. So I'm just calling the linked list, that is the doubly linked list, comma list name, which is the name of the links list. So we are using a method called insert begin. For first one we have created, that is list comma, let's say the element is 5. Next, let us insert another element at the beginning, list comma, let's say 4. So let us now insert another element at the end. So I'm calling the function which we have created insert end list comma 6. And I'm printing the list. So I'm calling the list name again here, and we have also created a delete, insert delete also, right? So let us call that as well. So delete at the beginning and pass the list parameter, and that's it. So we'll just print the list again, print list on the list. And fine. Oh, sorry guys, you have to mention a semicolon for each of them. I'm sorry for this, otherwise it will throw an error. And finally, if it doesn't return any value, I'm just returning 0. And mention the square brackets. I think we have to insert one more. So let us now execute the statement and we'll see the output. So as you can see, the list that we have created is 4, 5, 6, 7. So we have inserted 4, 5, and at the beginning, that is, since we have created a function insert begin, we're trying to insert the elements at the beginning, which is 4, 5, and 6, 7 are the elements that are inserted at the end. Now we have deleted 2 elements, that is 4 and 7 here. So 4 and 7 are deleted. Now the linked list becomes 5 and 6. So in this way, you can perform operations on doubly linked list, and I hope you understood this example. So let us take another file and try to implement the doubly linked list over here. Let me just clear this. So now I think it will be time taking if I keep writing all the code, guys. So I'll just copy paste the code that I've already created, and I'll just explain the various parts of the syntax on what we are doing. So if you look at the code here, again the header files are being written here. Now in this example program, we defined a node structure that contains a data value and a pointer to the next node in the list. So we also defined a global head pointer here, which is pointing to the null, and that points to the first node in the list here. Now next we have the add node function, which creates a new node with the given value, and it adds it to the end of the list. So let's say if the list is empty, it sets head to the new node and makes it to the point itself. So you can see here. Now otherwise it will traverse the list to find the last node, and it will add the new node after it by making sure to update the circular connection of the linked list. So the display function next, which we have created here, prints out the values in the list starting from the head and going around the circle until we reach the head value again. So this is the code, the snippet of the display function that we've created. And finally, in the main function, we are adding 3 nodes to the list with values 1, 2, 3, and then the display function, we are calling the display function to print out the content of the results. So this is just the basic code on the circular linked list. Now don't worry, we will leave the code of both the doubly and circular linked list in our description below, so make sure you check that out. So let us now just run this code and we'll see the output. So as you can see, 1, 2, 3 are being printed, which we have taken into our example. So I think that was pretty much about the circular, the doubly linked list, as well as the singly linked list, guys. Thank you for watching the video. If you found this tutorial informative and helpful, give it a thumbs up and share it with your friends and colleagues. If you have any further queries regarding any of the topics covered in today's session, feel free to let us know in the comment section below, and a team of experts will be more than happy to help resolve all your queries at the earliest. Stay tuned to the channel for more such amazing content. This is the other series, concept of another series of data structures where we have discussed about linked list, and the upcoming videos we will be discussing about another key data structure, which is stacks. So before we move and learn that, I would highly recommend you to check out the playlist of data structures where we have covered all the fundamentals, starting from what is data structures, various types that we have covered until now, like arrays, linked list, what is a structure. So make sure you check that out. We will see you in our next video. Until next time, stay safe and keep coding.